Hello, pre-algebra friends. Today we're starting chapter 3, which is pretty exciting because we really are going to get into solving harder equations now, and I think you're going to like it. I want to review quickly chapter 2 that we just finished. We really had just one-step equations in chapter 2. We had something like, for instance, if we had 3 plus x equals 10, we call it a one-step equation because once we subtracted 3 from both sides, our variable was alone and it just took one step. Well, in chapter 3, we have 2 and 3 step equations and even more. So once we have more than one thing we need to do to solve an equation, we're going to have some rules. We're going to have an order that we do our steps in. So I've listed the order, and this order will actually be the same that we use for section 3.2 and other sections in this chapter. The first thing you're going to look for is distribution. Do you have any distribution? How do you know if you have distribution? You're looking for the grouping symbols. You're looking for the parentheses and the brackets. If you do have distribution, you go ahead and distribute. If you don't, you go down to number 2. You're looking for like terms. We know those are the variables and the numbers on each side of the equal sign. Do we have like terms that we can add together before we actually begin to do our adding, subtracting, multiplying, and dividing? After we've taken care of collecting our like terms, we do the addition property of equality or the subtraction property of equality. That's adding and subtracting on both sides of the equal sign. And finally, the last thing we do before our check are any multiplication or division steps to get our variable alone. And then, of course, we check just like we did in chapter 2. Let's do it. Okay, problem number 1, box it up and rewrite it. Once I've done that, I'm going to look at my rules. I don't see any distribution because there's no parentheses. All of my terms are like terms and they're collected. I've got a 7x here and a 4 here. I don't have any more x's or any more numbers to add together. So now I'm ready to look back at my rules, and I am now at step number 3. In trying to get my variable alone, do I have anything that's added or subtracted onto the variable? Yeah, I do. There's a 4. The 4 is added. I'm going to do the inverse operation. Bring down the 7x, subtract 4 from 32, I get 28. And finally, my last step is getting rid of the 7 that's multiplied to the x. We will divide it. This is kind of strange because it's an opposite order of PEMDAS. In PEMDAS, we did multiplication and division before addition and subtraction. It's the reverse. Now we're doing our adding and subtracting first and our multiplying and dividing last. Let's look at number 2. Oh, we forgot to check number 1. That's not good. Let's go over here and do the check. We're going to go back to the original problem. 32. We're going to plug in for x. We think x is 4. Let's see if it works. 28 plus 4 equals 32. 32 equals 32. And it works. Let's run through number 2. Let's rewrite it. Let's ask ourselves, do we see any distribution? No parentheses. And actually, the distribution, I'll just give you a clue, it doesn't come until section 3.2. So none of the problems that we do today are going to have distribution. My like terms are collected. So now I ask myself, I'm on step number 3 right here. Do I have addition or subtraction that's attached to the variable? Yes, I do. I have this 1 who's added. I'll subtract. Bring down the 3x equals 12. And now I'm left with one lonely thing attached to the x. 3. 3's multiplied, so I do the division step. And now x is by himself, x is 4, and I'll do my check. 3 times x plus 1 equals 13. Let's plug in. See what we get. When we plug in 4, what do we get? We get 12 plus 1 on this side. And yep, my check is great. So I think you might have the idea on these two. I'd like you to work number 3. Let me get to the next page. I'd like you to work number 3 on your own, and I'm going to skip to number 4. So that's what I want you to work with me now is number 4, and you can go back and do 3. Let's box it up. Let's rewrite. I don't see distribution. I do see addition and subtraction, plus 8 to both sides. That leaves x divided by 3 on this side and a positive 4 on this side. I've got one more thing I need to do before x is by himself. That's multiply both sides by positive 3, the inverse operation of the division. And now I end up with x equaling 12. We think we're going to do our check step, go back to the original equation inside the box. X over 3 minus 8 equals negative 4. I'm going to plug in for x. I'm going to plug in 12. 12 divided by 3 is 4. Is 4 minus 8 minus 4? Hallelujah. We got it. So that was number 4. I will ask you to work number 5. It's similar. And number 6 as well. I've kind of stapled your papers funny. If you will find the page that has 7 through 12 on it, it's actually the second page. I want to skip down to number 9 and work number 9 together. Let's box it up. Let's rewrite it. There is no distribution, but there are like terms that need to be collected before we do any adding or subtracting or multiplying or dividing. These guys are like terms. Let's just add them up. Get them together. 3x and 8x is 11 x's. And now we have a normal old two-step equation left. We're going to do our adding and subtracting before multiplying and dividing. We're going to get rid of a 4 that's added by subtraction. That leaves us with 11x equaling 11. I see a little division in our future. Divide both sides by 11, and we get x is equal to 1. I'll leave the check to you, but I will remind you that we go back to the original equation. 15 equals 3x plus 8x plus 4. You're going to make your shell, and you're going to plug in 1 in each one of these spots, and then you're going to satisfy yourself that those numbers actually do add up to 15. Here, I'll go ahead and finish it for you. 3 plus 8 plus 4. So this is 15 is equal to 11 plus 4. 15 equals 15. The check is very important to me, so you'll want to make sure that you do them carefully and neatly. Number 10, it has like terms to collect as well, but this time it's numbers instead of variables. So you shouldn't have any trouble doing number 10 on your own as well. We're going to skip to number 11 because we're going to write some verbal sentences from these English words. We're going to write equations, and then we're actually going to go ahead and solve. So this is a two-step process. We're going to write the equations, and then we're going to solve them. So let's see what we have. 14, well, there's 14, minus, there's the minus sign, the product. We're in multiplication of 3 and a number. The product of 3 and a number is, there's my equal sign, 26. So let's get it a little closer together. 14 minus 3x equals 26. This looks like the problems that we just solved earlier. We've just created our own equation. It wasn't given to us. I don't see distribution. I'm going to box it up. I'm going to ask myself, are my like terms collected? Yep, they are. Now, do I have anything added or subtracted onto this negative 3x? Yeah, I've got this 14, and he's positive, so he's added onto there, so we're going to subtract 14 from both sides. Don't forget this negative. When you bring down what's left, negative 3x equals positive 12. Now we're going to figure out what do we need to do. Our last step to get the x by itself, divide by negative 3. We're dividing by exactly the same coefficients, sign and all. And x is equal to negative 4. And we're going to check it by just going back and making sure that when we plug in negative 4 for x, do we really get what this thing says? So let's look. 14 minus 3 times negative 4, is that really 26? Well, 14 and a minus 3 times a minus 4 is a positive 12. That is 26. And we're good to go. So I'd like you to do number 12. And now if you'll skip to the back page, skipping around again. I've got to get a couple more minutes in, and then I'm going to have to stop. I want to skip to number 14. Actually, I'll set up 13 for you. So 11 minus, there's the minus, the quotient of, we're talking division, so we've got a fraction bar. Quotient of a number, x, and 8 is, here's my equal sign, 15. Let's bring it closer together. And I'll ask you to go ahead and finish that one. I want to talk about number 14. It's a little bit different. The second of two numbers is 5 more than the first. Their sum is 29. Whoa, I didn't do a good job of drawing that line. The second of two numbers is 5 more than the first number. So let's let our x equal the first number. If the second number is 5 more than the first number, then we can write the second number as x plus 5. So we're just using one variable, x for the first number, and whatever x is plus 5 more gives us the second number. Now we're going to write an equation. It tells us to add them up. Their sum means equals 29. So it says add the numbers together. Here's my first number. Here's my second number is 29. There's my equation. Now I need to collect my like terms. I've got an x here and an x here. That makes 2 of them. And now we're just going to work it normally. No distribution, no collecting like terms because I did that up here. Now I'm going to subtract 6 from both sides. And I get 2x is equal to 23. That's kind of ugly because when I divide, I'm going to get a number that's got a decimal. But that's okay. X is equal to, and 23 divided by 2, if you have to do it longhand, that's okay. So 11 and a half, 11.5. That's the first number, 11.5. The second number is 11.5 plus 5. That's 16.5. And when you add them up, 5 and 5 is 10. 6, 7, 8, 28. I've made a mistake. I've made a mistake. What did I do wrong? Can somebody find my error? See if y'all can figure out what I did wrong. Oh, look what I did. I added 6 instead of 5. My check showed me that I had made a mistake. So I think we'll get an even number now when we go back and fix it. I'm going to let you go back and fix it, and we'll talk about it in class. All right, I've asked you to do some equations. At the bottom, there's 4 to use notebook paper. I'll be interested to see your work, and thanks for listening. I'll see you in class. Bye-bye.